So good day guys, so today we're going to talk about potentiometry. So the content in our topic for today are the following. The principles of utilizing potentiometry as method of analyzing pharmaceuticals, the application of potentiometry as method of analyzing pharmaceuticals. And we have also a video or link that you can watch regarding potentiometry for further knowledge if you want to learn more about potentiometry. So, potentiometry is the field of electroanalytical chemistry in which potential is measured under the condition of no current flow. Potentiometry is mainly used to determine the potential or electromotive force of a sample solution. So, the potential is directly proportional to the concentration of the ions. The potential difference is determined by the electrochemical cell, which is composed of a pair of electrodes, namely the indicator electrode and the reference electrode. So, we have the principles in utilizing potentiometry as method of analyzing pharmaceuticals. So, the principle involved in the potentiometry is when the pair of electrode is placed in the sample solution, it shows the potential difference by the addition of the titrant or by the change in the concentration of the ions. So this can be seen below. We have, as you can see, we have here our reference electrode, reference solution, indicator electrode, sample solution, and the salt bridge. So the reference electrode is the electrode which consists of its own potential value and it is stable when dipped into the sample solution. The salt bridge is used to prevent the interference of the analyte solution with the reference solution. Analyte solution is the sample solution whose potential is to be measured. And lastly, the indicator electrode is the electrode which responds to the changes in the potential of the analyte solution. So next, I'm so sorry about our slide because I cannot convert it to PowerPoint. If I convert it, it'll be mess. So next.
Application of potentiometry as method for analyzing pharmaceuticals. Used in the determination of the percent of acetyl salicylic acid in the aspirin tablet. Used in the determination of the percent acetic acid in the vinegar. Used in the determination of the carbonate. Used in the acid-base titration. Used in the precipitation titration. Used in the complexometry titration. Used in amperometry. Used for the estimation of the saccharin in the food components.
So, here is the video or link regarding potentiometry. If you want to learn more, you can just click this link here. And so moving on.
Ash content. Total ash is the residue remaining after incineration. Content represents the incombustible component remaining after a sample of the furnace oil is completely burned. Acid insoluble ash consists primarily of silica and silicates. This material, when present in the finished paper or paperboard, can have an abrasive effect on punches, knives, slitters, and dies, which come into contact with paper during finishing operation.
Approximate temperature equivalents. A clear saturated aqueous solutions, unless otherwise specified, of volatile, very dull red heat 500 to 550 degrees Celsius, dull red heat 570 to 700 degrees Celsius, bright red heat 800 to 1000 degrees Celsius, yellow red heat 1000 to 1200 degrees Celsius, white heat 1200 to 1600 degrees Celsius. Residue on ignition or sulfated ash test. A method to measure the amount of residual substance not volatilized from a sample when the sample is ignited in the presence of sulfuric acid, depending on this procedure. This test is usually used for determining the content of inorganic impurities in an organic substance. Loss on ignition. Loss on ignition is a test used in organic analytical chemistry and soil science, particularly in the analysis of minerals and the chemical makeup of soil. It consists of strongly heating a sample of the material at a specified temperature, allowing volatile substances to escape until its mass ceases to change.
Water content. The principle of the six methods that determine water content. First, gravimetric for drugs containing no constituents other than water. The water content is determined by a process in which the drug is dried at 105 degrees Celsius until there is a constant weight. Second, gravimetric for drugs containing ether-soluble constituents. Determination can be carried out either by heating 100 to 105 degrees Celsius or in a desiccator over phosphorus pentoxide or under atmospheric or reduced pressure at room temperature for a specified amount of time. Third, toluene distillation. Moisture is removed from the sample by distillation as an azeotrope within toluene. The water is collected in a suitable trap and its volume is measured at a known temperature. This method is specified for the determination of moisture content of many vegetable drugs containing 2% or more of moisture. Fourth, titrimetric. The principle of Carl Fisher titration is based on the oxidation reaction between iodine and sulfur dioxide. Water reacts with iodine and sulfur dioxide to form sulfur trioxide and hydrogen iodide. An endpoint is reached when all the water is consumed. Fifth, dew point. In dew point method, the dew is found on the walls of container at a temperature where the air is in contact with it and gets saturated. For drugs with low concentration of water. Sixth, electrolytic hygrometric. Measured airflow is passed around the platinum electrodes with phosphorus pentoxide, which absorbs water. When voltage is applied to the electrodes of water decomposes into hydrogen and oxygen. Electrolysis current is proportional to the amount of absorbed water. Example, absolute humidity for drugs with very low concentration of water.
So that would be all. Thank you and God bless.